Right, let's continue discuss this example. Alright, after explaining the concept of continuity, I'm going to use this function as an example to explain about the continuity, right? So I will rewrite the definition here. So the definition of continuity, alright, definitions of continuity. So we say that fx is continuous at point x equals to a if the first condition will be the limits as x approaching from the right and from the left must be exactly the same. Alright, these two must be the same. Let's say you're getting L. Secondly, if these two values, the right and the left, the limit are the same, definitely you know that the limit as x approaching a for fx exists. Exists means there is a value. Let's say if this one is L, this one is M, the value are different, so means there are no value for this, right? So this is the first condition. Limit must exist, the first condition here. So I can combine these two as one condition. So the second condition will be, so the third one will be, the value of at that point, the value of f at that point must be defined. Must be defined. Define means there is a value. So the value of the point must be also L. They have value. If the value is not L, they are not continuous. So this is the priority for this section here. So about the concept of continuity. Alright, what is this? There is a question mark. Okay, so let's look at this. Let's look at this. So they said the continuity at the point x equals to a. Now is 1. Alright, at x equals to 1. So of course, by follow this definition, you have to. This is like a checklist, you know. You have to check everything here. A complete one, okay? Don't do any shortcut here. So, x approaching 1 plus. According to here, you must have 1 plus. You must have 1 minus. Alright? So, you have limit as x approaching 1. So, the first condition here. So, let's see. More than 1, right? 1 is approaching from the right. More than 1. So, more than 1, the function is x power of 2. So, for this one, left, 1 means less than 1, right? Less than 1, which is 2x minus 1. Let's see. You can directly substitute the point here. 1 square, you're getting 1. Alright? You're getting 1. How about this one? You substitute. You 2, 1. 2 multiply 1. Minus 1. You are getting 1 also. Is the limit exist? Is the limit exist? Yes. Secondly, limit exists. We have passed the first test. Good. Second test. Second is come from number 1, which is limit exists. We know that limit as x approaching 1 of fx. Fx is considered these two, right? So at this point, the limit exists 1. So, okay. Right? Limit exists. But is it continuous? Not sure. You must go for the third condition here. If the question asking about limit exists, 1, 2, good enough. But if they ask for continuous, then the third condition must come. So it means that you have to check the FA. The A here refer to 1. So F1, what is the value of F1? Then we have to look at the piecewise function here. Can you see there is an equal? There is an equal here. So it means that this is actually x equals to 1. It's not approaching. It's not approaching. It's 1 exactly. So you can substitute the 1 into this function, not this function. There are no equal here. So substitute. So you have 2, 1 minus 1. You have 1. Now they also pass the third condition where L, 1, 1, 1. Yes. So therefore I can say that fx is continuous at x equals to 1. What's the reason? What's the reason? If the question asks for the reason, what is the reason? The reason will be very simple. Just write this statement. The limit as x approaching 1, right? is equals to what? Equals to f1. Equals to f1. Because these two, the value here must be the same, right? Means the limit of x approaching a fx must be the same as fa. So this is the very short reason. Easy and precise. Okay, now limit approaching x from 1, which is 1, f1 also 1. So it's continuous. So I'm going to show you the graphical. Alright, the graphical. So, alright, let's see what's the graphical representation of this case here. Alright, let's look at the graphical representation here. So you go for very detailed. So you understand this concept in a very detailed way. So now x 0. So let's look at this graph here. Less than 1, right? 1 is the boundary here. So before 1, there is a linear graph, 2x minus 1. So you can substitute 1. Substitute 1 here, you're getting 2, right? You're getting 1, right? You're getting 1. And there is a solid circle. Why solid circle? Because there is an equal here, right? F1 is defined. F1 is defined. If there are no equal here, F1 is undefined because 1 does not belong to here, does not belong to here, right? So now there is an equal, so F1 is defined. So then you know 1 here, and they were passing through negative 1. Why? Mx plus c, right? Y-intercept. So x squared, when x more than 1, right? When x more than 1. So you know the graph for x squared will be this way, right? X squared. So you substitute 1 here. 1 square. 1 square, you will have 1. You have 1 also. So, but the graph for x squared is how? You know the graph for x squared is passing through 0, right? So during 1, it is 1. So means we only want this section here. We only want this section here. This section here. So if you draw, so you were looking like a quadratic, okay, not a quadratic. So means that if you look at here, the limit exists. The limit x approaching 1, either from the right is 1. Okay, this question I'm talking very long because I wanted to understand the concept. So 1 plus, so 1 plus is 1. Alright, approaching from the right is 1. Approaching from the left also 1. And F1 also 1. Alright, so these three values are the same. Right, left at this point. So we can say that they are continuous. Okay, continuous means if you're walking, there are no hole here, right? No hole here. So you still can keep walking. Okay, now, if not continuous means jalan, mata tak tengok, jatuh longkang. Okay nak? Jatuh. Alright? Jatuh. So not continuous lah. You don't, this is called not continuous. Alright? So for this video, I'm talking only for this concept here. I go very detailed. So in the next coming video, I want to teach you how to evaluate the continuity at a point. Alright?